Alright guys, we're going to be working on that fixture that I showed in last week's episode. We got this piece of aluminum here, 6x6 by probably 1.5 inches. We're going to be turning this into that V-block fixture. So what we're going to do is I'm going to have to change my dual station vise into a single station vise so we can actually hold on to this thing. And then what we're going to do is we're going to square up at least two sides of it, deck the top and bottom, and then we're going to machine these long V-channel grooves. There's going to be 10 of them, so in theory we could hold 10 pieces of material upright like this, and then we're going to have to make a separate clamping block of some kind to actually push into those pieces and hold them. And then what we'll also do is we'll take this and we're going to machine a pallet here. These are 150 millimeter pallets, and that way we can put this upright like this, and we can in theory pallet change this at some point. So I'm curious to see how much this thing weighs. We might do a before and after. This thing's pretty hefty, so that is the current plan. So I'm going to swap out the vice jaws so we can actually hold this thing, and I'm going to start decking this down, and we're going to run that program. It takes about 1.5 hours, so hopefully I can find something else to work on in the meantime. I'll probably sit down and start looking at more cam and then also figuring out the clamping block that I mentioned. But before I get to that, thank you guys for all the comments and all the follows on Instagram. We're up to, probably by the time you're seeing this, 100 followers. I think we're at like 98 right now on Instagram. So make sure you guys go over to Instagram, link in the description, and hit the follow button. And then also thank you to all the people that are commenting on these videos. Guys, I love the comments. So even if you're a repeat offender, drop a comment, let me know what you guys like, what you guys are thinking, and let's get into this. So my guess was 10 minutes to get this set up. Took about 7.5 minutes. That's not bad. So the only reason I'm putting this 1, 2, 3 block here is because I don't want to have to change the jaw position back and forth. And again, we're not taking that heavy of a cut. So we're going to deck this side, flip it 180, and deck it so we have at least 2 reference surfaces to clamp on. And yeah. I also just love how my bracelet is in all of these shots. I think that is awesome, so very happy with that. So let's go ahead and clean up these edges here. One thing I want you guys to comment down below, do you guys like the machining side of things, like actually seeing the cuts happen? Or do you like kind of the whole story and the process of what I'm trying to accomplish? Because I feel like I don't show a lot of machining shots simply because it is annoying to film through the doors, and some of this stuff I feel like is very like basic machining, like facing this, that type of thing. So I'm curious, drop a comment if you guys want me to share more of this and get better setups to film through the doors, or maybe even a GoPro. But let me know if that's what you want to see more of, less talking, more machining, or if you like the combination and the flow that we have, where I try to show as much as I can. Let me know what you guys think. I want to make these videos as good as I can for you guys. Alright, so let's do 8,000 RPMs. We're just going to manually go down here. Right there, spawn. We'll go down. I don't know, I'm going to go down like 40,000. I know this isn't the high spot, so I'm just going to keep that in mind. We might actually, no, we didn't clean up. So let's go down until we touch here. Wow, that's quite a bit. All right, now we're touching. That was like, I don't know, 70 thou at least. And we're going to have to come down a little bit more because that's still not even cleaning up. We'll come down another 20. I don't know if you guys can see those chips, but it's like right behind the spindle, but they're definitely coming off. All right, that side is very much cleaned up. Oh yeah. All right, let's go ahead and actually leave this open. I'm just gonna get this out of there a little bit. All right, we're gonna deburr this and then we're gonna flip it. All right, so we just did the other side. Let's take this guy out of the vise. Deburr this bad boy. Make sure you guys still see that. Yep. I don't know about you guys, but I love using a file to deburr versus like the little Noga tool. I don't know. I feel like I have more control over how much it bites in. And so luckily with this fixture, it's not too accurate as far as like these dimensions go. So we'll measure this, make sure it's square, but it really doesn't matter. We can make the fixture to kind of what we have here, which is nice. Not always, you can't always say that. So it's funny, I can already tell it's a little bit lighter. Okay, so we've got our two machined edges here. I'm going to double check that this is square. I guess we could show that, why not? Alright, let's see. Let's see what we got. So we got 5809. 5810, so within 1,000. So that I am more than happy with. All right, so now I think what I got to figure out is obviously we can hold it like this now in the vise. We could clean up these two ends if we really wanted to. Yeah, we won't be able to touch those in this orientation. I'm trying to think. Doesn't really matter. We're just going to want to at least have some edge to probe off of reliably. I guess we could put this in parallels. We could stick one end out, clean it up, and do the same on the other side just to get it square. That's probably what I'll do. And then once I get those dimensions, then I can actually get an X and Y dimension here. And then I can figure out in cam which way I want to orientate the fixture, long ways or short ways. I think we're actually going to be 5.9. Yeah, it's going to be pretty close. We can actually shoot to make it truly square, so 581. So we could try to shoot for that in this direction as well, just to keep it simple. So let's go ahead and open this up. I like that idea. We'll make it square just to keep things easy. And then it'll also make things for probing nicer. Okay, so probably just use those. Yeah, that'll be fine. So I'm going to stick this out a 1/4 inch or so, make sure the parallels aren't in our way. This would also be a good opportunity to face this. So I'm just making sure the parallels are tight. Again, we're not putting much cutting forces on this. This is actually a good question though. Do I have a tool that's long enough to cut that in the machine? I don't know if I do. It would have to be my 3/8 end mill, but I don't even think it's close to that long. So we might have to put a tool in there. So let's think about this for a second. Okay, so I found a 1/2" end mill that's definitely long enough. I'm just gonna pull this tool out, manually cut these, and then put that back in. I gotta remind myself that is tool 10. Gotta make sure we put that back in. So let's go ahead and swap that. All right, now what we can do is we can manually come in here down as far as I can to just keep the rigidity. So the tool's probably a 1/4 inch past the part, but I want to get as far up on that shank as I can. So, you guys still see that? The window definitely likes to fog up. That's not bad. Okay, so I'm thinking slow and steady, so I'm thinking like 6,000 RPMs. And then we're just gonna go in slow. That's not slow. All right, we're touching there. I might run coolant on this. Let's see how this behaves. I mean, that was just a touch off. All right, yeah, that sounds pretty good. So this was definitely the heavier side here. I can see the chips are getting bigger. Yeah, look at this. I haven't made chips like that in a long time. All right, now I gotta stick my head in there. All right, so it cleaned up everywhere except for the back. I'm willing to bet like 20 thou, and we'll be good. That's 20. I'll try to go a little bit faster here. Oh yeah. Oh, maybe. I couldn't see it. It stopped making chips there at the very end. Oh no, that's beautiful, guys. That's so beautiful. I'm gonna get my camera. Again, not like it needs to be beautiful or anything, but I will take that. So we're gonna flip it and do the same thing and try to hit that number. If we come close, that's fine, but 581, that's our number. Alright, well, I was not expecting to make that many chips, but we cleaned up this face now, and it's exactly the same dimension, so 5.81, so we nailed it. So now I'm going to take this out, deburr this, and you know what, actually I might deck this real quick while we're on this side, so then we can flip it and have both sides face. So I'm going to go ahead and do that actually. Alright, we got to remember to take this tool out. Probably should have used coolant. But it's fine. Alright, so we'll take this tool out. We'll put in Mr. Face Mill. This face mill I've had since I had my first machine in 2018. I don't think I've ever flipped the inserts, even though they are beyond needing to be flipped. But yeah, this is a whole mess. All right, we will deal with that in a little bit. Actually, we'll just leave this open for now. All right, so I'm just going to manually deck this again. I don't think we'll deck this. This is just purely cosmetics and to square. And then the other side, if you want to bring it to a specific thickness, we can do that on the other side. So that's kind of my thought process here. So I'm going to bump it back up to 10,000. I just want enough to clean this up. I don't really care about anything else right now. We'll do that. Come over. Do that. Come over. See, this is one of those things, this is like the classic machining argument of, yeah, I could make a program to do what I just did, but you saw how quickly that was, and now we have it faced. So, again, I'm going to take this out, deburr it. Yeah, that's pretty nice. And we're going to flip it over, recenter it up here, and see what we got. Okay, so we have to reset up because although this is perfectly square, which is awesome, I actually need this to be 5.1 tall for our fixture. We can't have it much taller than that, and that already might be pushing it. So we have to take, what are we at, 5.81 down to 5.1. So we got to take quite a bit off the top here. So I'm just going to do it manually again. I'm going to just be a little bit more accurate on my touch off here, and I'm just going to manually take notes and take it in a handful of passes here. So again, I figure that's going to be the fastest. So that's what we got to do real quick. So I can easily take 100 thou at a time. But I feel like I should be running coolant. So I probably don't have to, but I'm going to. So here we go. Time to make a mess, and sorry about your viewing pleasure. I'm going to get my mist collector going. Alright, I'm actually going to do faster jog feed rate, and I'm going down 50 thou. All right, so we're already down a 1/2 inch. I'm gonna go down to, that's 600. I'll go down to 700 and then I want to measure. All right, so that's 700. All right, I'm gonna let my mist collectors collect some of that before I open up the doors, but that was 700. We have to go down 5.81 minus 5.1, so another 10 thou, right? Yeah, we want 5.1. Yeah, so let's go ahead and take a look at what we got. All right, so I just measured. I only moved this in Y, so our Z should still be where it was at. We're right on the money. I mean, I'm 9, 10, 11 thou. Obviously, my measuring stick isn't that accurate in this direction, so I'm gonna just go down. I'm just gonna go down to 10 and face that off. And this time, we probably don't need to do any coolant. So let's go down 10 thou. I don't think I was fully over it in Y. So just like that. Again, I'm going to move off that just in Y. Bring this over to me. And again, this is not super critical. But I will take that. So yeah, okay, so now I'm gonna take this out, deburr it, flip it over to the non-face side, and then we can get our program running. So let's go ahead and do that. Can already tell you guys, this thing's already way cuter than it was. Nice and squared up and a lot smaller and a lot lighter. It's still heavy. I mean, this is still a few pounds for sure. So now I'm going to flip it here on our non-face side, and that's where we're going to probe it, we're going to face it, and we're going to cut those V grooves in it. So let's go ahead and set this up here. All right, let's go ahead and probe this bad boy. Something like that. We'll go over to our probing setup. Let's see, what offset do I want? 57? We'll do 58. I do want to probe the Z. X is 5.81. Y is 5.1. And something like that, something like that. Alright, so there's our Z. Let's do our X. And our Y. Okay, so that is set up. Now the only other thing we need is a 1/8 inch ball mill in the machine. So let's see. I'm gonna have to do a tool change here and swap out. I'll probably swap out this guy here. So let me go ahead and do that. Okay, so I just faced it and I reprobed the Z just now. I got the program loaded, I got the 1/8" ball mill. What we're gonna do is we're gonna take tool 22, which is a 3/16 end mill. We're gonna rough the slots. We're gonna come in with an 1/8" end mill, go all the way down to like the V point and do 2 contour passes to rough out a little bit more. Then we're gonna come in with the ball mill and we're gonna surface this. The whole program takes around 1:45. I'm gonna put an option stop on and double check each of the first 2 tool paths. But without further ado, let's get this going. So, so let's see. Yeah, so again, I love working efficiently as I can. In this scenario, like I said, I'm gonna throw on option stop. I'm gonna go start making some lunch. And then by the time these first 2 tool paths, I think they're only like 20 minutes long, I'll come out here, double check it, and then I'll get the last one that's about 1.5 hours running, and I can go do something else. So, tool 22, I've got it set for through spindle coolant. I don't think that's really necessary, so I'm going to change that to M8 instead of M88. It's going to take a second here to save that, and then we can go ahead and get this running here. First. Give it a little bit of coolant here. Start the main tool path. Let's go. Really like, I don't know, sometimes these adaptives, I mean, you have 0 control over certain things, so, and at the end of the day, I don't really care, but it is interesting sometimes. There we go. Yeah, that's just gonna sit here and chip away. So yeah, I got option stop on. We're on 5% rapids. I'm gonna go get some food going. All right, you can see the rough marks from machining that. So now we're gonna bring in our 1/8" ball mill and we're gonna finish that out. All right, here's some in-process machining. You can see the finishing we've done up front and then the roughing in the back. So we're gonna just let this run. This has already been, I don't know how long. So since I interrupted it, I don't know, but let's keep going. All right guys, we are done machining these V grooves here. So now, the real test. Aha! As you can see, a bar fits in there nicely. There are horizontal machining lines. If anything, that might add a little bit of grip, but I'm pretty happy with this. So now what I'm going to do is I'm going to install a, let's see, 1024 tap, and we're going to tap some holes along these edges here while we have it in this orientation. And then we're going to flip it up on its end and also tap a few holes that'll be our threads for our pallet. And then we're also going to be putting some pins in to clock it perfectly. So let's go ahead and drill and tap those holes. and tapped these holes here. Now we're going to take this out and we're going to flip it up, and we're going to do some more, like I said, on this edge here, and this will go into the pallet. Alright, we just are about to tap these. We're doing, let's see, 2, 4, 5 tapped holes, and we have 2 1/4-inch pins here. I've done a lot of press fits of 1/4-inch pins. I do this a lot, and I love it because I nailed this first time. This is not a press fit, but it's a very nice precision fit. So those will align nicely. We can make the pallet a little bit tighter, but that'll just make sure everything's straight, and then we got 5 bolts to bolt this thing down. Okay, I did some machining off camera. We drilled and bored some of these holes, reliefs for the screws, and then I reamed these 2 holes. So now the bolts should drop through. That might be too much sticking out, so we might have to either cut that bolt, or I think that's the only real option here. So let's attempt to do final assembly. I'll do what I know I can do first, which is I can put this seal back in. Make sure you guys see all this. Put this seal back in. We can take, is this the best angle? That's not bad. Let me move this over a little bit so you guys are a little bit closer. Okay. So put the seal in. This basically makes the pallet on the Rock Lock 5th axis system. They have a small 10 thou hole drilled in the center of the Rock Lock 0-point system, and having this seal in here, they push air through this tiny little hole, and this seal creates like a sealed off section, right? That this allows it to push off of the Rock Lock. It's kind of a feature that adds some reliability, because sometimes these pallets can get pretty stuck. 4 pull studs, in my opinion, is kind of an over-constrained system, but that's another discussion. So I'm going to lightly torque those down. Okay, so that's there. Next is this little plate here on the end, and this is for the automation system, or the automation side of things. So we have this little cleat. This is what the robot grabs onto. It's got some small, I believe these are 1/8-inch pins, and then we put this plate on there, and that way the robot gripper isn't hitting up against aluminum, it's actually hitting up against steel, which is obviously, from a longevity perspective, a lot nicer. So that goes like so, and then we have 2 countersunk screws here. So we'll put those in. Again, I had to take these out just to probe the block, and I didn't want this to be in the way. So hopefully everything, I'm trying to think. So we're not going to be able to finish this today. The only thing that we're going to need technically is that clamping block, and we might show that, or at least the rough design that I have. Okay, so that's in. Next step is, let's just pretend, so this would be like so, and let's just tip this over, and let's just make sure that these even line up. Make sure that's clean. Oh yeah. So now the question is, I think those bolts are going to be too long. I know you guys can't see this, but I just want to test with one bolt first. Yeah, those bolts are going to be way too long. So, that being said, how much we got sticking out? These are all the same, right? Yeah, so let me get my calipers. I tapped this part. I drilled it 500 and I tapped it 400. So let's see what we have here. I bet you it's close. Yeah, 423. So I could tap, I bet you I could manually tap these a little bit deeper and it'd be fine. Oh yeah, there's plenty of room in there. So that's what I'm gonna do. I'm gonna take that tap out and I'm gonna manually tap these a little bit deeper, and then we should be able to assemble this. All right, note to self, always check if you have shorter bolts. That saves a lot of time. I just tapped all of these and then started grinding down some bolts, but I realized I've got shorter ones. So of course that would happen. All right, we're back. Let's see if Mr. Shorter Bolt, actually we should probably put these in first. That'll get us the line. Okay. Might need a little persuasion. Just want to make sure those are still sticking up. Is one of these sides, I guess even if they go all the way down, they're still going to be engaged, so we're good. All right, we got to give this a little love tap. Okay, so that's seated all the way. Let's go ahead and try putting these. Man, this one screw came so close to our little seal. All right, so that's 5 bolts. Why is that one not starting? All right, let's do this one then. Okay. Okay. Fixture building is always, I don't know, I feel like it's one of the most satisfying things when multiple pieces you machine come together, because making one part to spec is obviously its own thing, but having multiple parts go together that you had involvement with all of them is very satisfying. Alright, why wasn't this one? There we go. Okay. Alright, we are pinned. Those are all snug. I'll probably tighten those down a little bit here in a second. That would be our fixture, guys. So again, now we can take pieces of material like this vertically. So we can take pieces of material like this. Obviously it won't be this freaking long, but 6 inches is only a little bit far past this, because this is 5.1, I believe. So the only thing that we need to do is make that clamp that'll go across the top, and that way we can have our set screws push in on this material. Now, I have this piece of aluminum here that I think would work really well for this because it's really thick. I'm pretty sure this is cast aluminum, so I'm not a fan of that, but I think I'm out of time for today. It's getting to be about 4 p.m. and I still have to edit this video, so I think this is really good progress, though. I mean, that's going to hold really well. And then obviously, so that was 3/8, and let's say this is 1/2 inch. This would also work, and then it also should work with 1/8 inch stock, which is what we make the screws out of. So again, I'm pretty stoked with this. The only other, I guess, little piece of assembly here that we could technically do is we got to put the studs back in on the bottom here. So again, I'm not like striving for automation right off the bat. I just know that I have these pallets, and it's the only work holding system that I currently have on the 5-axis portion of my machine. So I figure we might as well start by standardizing off of what we have here, and if it works and we can pallet change it down the road, we're already, we're already been thinking about that. So that's kind of what I've been thinking. And one other thing to note, this was like an old pallet. I don't know why I had this tapped hole array. I think it was for a different fixture, but I didn't want to use one of mine that had a vise on it already. So, and I'll go back through and I'll torque all this down. Like I said, I'll probably put it in the mill vise here just so I can hold it a little bit better, but we can at least talk while we put in some of these studs and whatnot. So again, I'm pretty stoked with this. So I think the next step is obviously making that clamp and then testing that out. And I think at that point, we can start making links 10 at a time, which we still have some trial and error to do on that program. It's not perfect, but it's definitely as close as we've ever been. So there we go. There's our pallet. Okay, so I would say this is a successful day. It took a lot longer than I thought, but I think doing it right the first time, I think is going to really pay off with something like this. Again, we have to make that clamp that goes across the top. I have a few concerns about that. Hopefully we can do that pretty quickly next week. Again, I'm strapped for time. I also have to reset this machine back up to a dual station vise to start production tonight for brick tactile stuff. So I'm kind of balancing in between two different businesses here. But this feels really good. I'm very happy with this. We've got everything we need to have it pallet changed down the line. It's on our standard 150 millimeter pallets, which is awesome. And this should be freaking awesome. The one thing that we haven't done is, if you guys remember from last week's episode, I showed there was some different angled cuts on the back here to give us clearance when we rotate it down like this for a tool holder to come in like that. That will come when this actually gets mounted into 5-axis, because I can easily just tip this at an angle and just face it down, so I didn't want to do that just yet. But that's the fixture, so let's get a thumbnail here real quick. So yeah, I'm really excited. Guys, drop a comment, and also I wanted to do a poll on this video. Maybe I'll do it on the next one. But guys, thank you so much for watching. I hope you guys are excited to also wear a Modarra bracelet, fully machined in Seattle, Washington. None of this mass-produced jewelry. This is fully machined by a machinist, for machinists, for awesome people. So that's what we're trying to build here. All right, guys, thank you so much, and I'll see you next week.